assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So um, to to find out the highest possible oxidation state the for the first row of the transition metals, what we need to know is that all the elements they tend to find out an oxidation state in which they will have an electronic configuration of the noble gas, or they will have a stable d orbital configuration, like half filled d orbital of d5, like d5 configuration, or d10 configuration, or a noble gas configuration. So these are the electronic configuration, and which oxidation state can provide this kind of electronic configuration. The that is the highest possible oxidation state for the first row or any row of the transition metals. So +3 transition state is the highest possible transition state of um, iron and scandium. So if we look at the electronic configuration of iron, let's see, iron has electronic configuration of this. Argon is the preceding noble gas, and then it has 3d6 4s2. So for having +3 charge, we need to remove 2 of these s electrons and 1 of these d electrons. So Fe3 plus will have an electronic configuration of argon, and then 3d5. So as we said that if in the electronic configuration, if the transition metals have a d5 um, electronic configuration, that is more stable than any other electronic configuration, and that's why Fe3 plus is the highest possible oxidation state for iron. And in case of scandium has a electronic configuration of argon, and then 3d1 4s2. So for Sc3 plus, we will have to get rid of all of these, both of the 2 of s electrons and 1 d electrons. So Sc3 plus has an electronic configuration of argon. Then so for the first row transition metals, +7 is the highest possible electronic configuration for manganese, because manganese has an electronic configuration of argon, and then 3d5 4s2. So if we need to form Mn7 plus, we'll have to get rid of all of these d and s electrons, and Mn7 plus will have electronic configuration of the argon. And then for having a +4 electronic configuration, this is the maximum or highest possible electronic configuration for titanium, because titanium has an electronic configuration of Ar, and then 3d2 4s2. So if we want to form Ti4 plus, we'll have to get rid of all these d2 and s2 electrons, and Ti4 plus will get a noble gas electronic configuration, and that's why it is the highest possible oxidation state for titanium.